In 1842, Australian physicist and mathematician J.C. Doppler proposed the Doppler effect. The Doppler effect is an increase or decrease in the frequency of sound, light, or other waves as the source and the observer move toward or away from each other. Without motion, the Doppler effect cannot occur. Sound is a longitudinal wave that results from the back and forth vibration of the particles of the medium through which the sound wave is moving. A longitudinal wave consists of compressions and rarefactions. A compression is a region where the particles are closest together, and a rarefaction is the region where the particles are furthest apart. Pitch is the highness or lowness of a sound. Frequency is the number of waves that pass a fixed place in a set amount of time. The higher the frequency, the higher the pitch. In the direction the object emitting the waves moves, the wavefronts bunch up, and behind it they spread out. If the object is moving toward the observer, the waves are observed at a higher frequency, and if the object is moving away from the observer, the waves are observed at a lower frequency. Say you are standing on the side of the road and a police car passes by. As it is approaching, the pitch of the siren seems higher, and as it moves away from you, its pitch appears to be lower. But why? As the vehicle moves towards you, the sound waves bunch up, increasing the frequency and therefore increasing the pitch. As the vehicle moves away from you, the sound waves spread out, and so you hear them at a lower frequency and therefore a lower pitch. It is important to realize that the change in frequency does not result because of an actual change in the frequency of the source. Let's go back to the police car example. Just because you hear the siren at a different pitch as it moves toward and away from you does not mean that the pitch is actually changing. If a star is moving toward you, the light waves that intermit will be bunched up, meaning you see the light at a higher frequency than it actually is. Frequency in sound is pitch, but what is it for light? If we look at the electromagnetic spectrum, we will see the small change in the frequency for visible light will result in a color change. Higher frequency light means a bluer light, and lower frequency light means a redder light. This is called redshift. Stars change color based on their relative motion to you. Of course, we can't see this change, but astronomers with the right equipment can use this effect to tell whether stars are moving toward or away from Earth. All stars that have been detected are redshifted, which is one piece of evidence for the theory that the universe is constantly expanding, possibly because of a Big Bang.